Chapter 1 Method 1.3 Stoichiometry Part 2 1.3 Stoichiometry. At the end of this topic, students should be able to define limiting reactant and percentage yield, perform stoichiometric calculations using mole concept including limiting reactant and percentage yield. Limiting reactant and percentage yield. Look at to this analogy. To make one sandwich, we need 2 slices of bread and 1 slice of cheese, like the figure below. Now, provided with 28 slices of bread and 11 slices of cheese. So, how many sandwiches that we can make? Thus, we can make 11 sandwiches and there are 6 slices bread left over. Thus, which one limits the amount of sandwich formed? Good. The answer is cheese. If this were a chemical reaction, the cheese would be the limiting reactant or the other name is limiting reagent. So, we can define a limiting reactant. A limiting reactant is the reactant that is completely consumed in a chemical reaction and limits the amount of products formed. Now look at the other reactant, bread, which do not limit the amount of product are in excess. Thus, we can define an excess reactant is the reactant that is not completely consumed in a chemical reaction and remains at the end of the reaction. Now, look at the definitions of theoretical yield. Theoretical yield is the amount of product that can be formed in a chemical reaction based on the amount of limiting reactant, while actual yield is the amount of product actually obtained from a reaction. The actual yield is always equal to or less than the theoretical yield because a small amount of product is usually lost to the other reaction or does not form during a reaction. So now, look at the relation between theoretical yield and actual yield by given formula. The formula is percentage yield equal to actual yield divided by theoretical yield multiplied with 100. Alright students, I'm going to mention you if you have to answer the questions with having a mass of product given, so that is assigned as actual yield of the reaction. Okay, so how can we have to solve the questions involving limiting reactant? There are 2 methods to solve it. First of all, we're going to write a balanced chemical equation, which having reactant on the left and product on the right. And also, both reactants and products have their own stoichiometric coefficient. 2 methods to determine limiting reactant. The first one is stoichiometric method and the second one is ratio method. And I'm going to emphasize you have to answer the questions of MCQ by using ratio method. Okay, look at first to the stoichiometric method. The first step, you have to write a complete equation. Complete means you have equation, reactants and product, and you have to balance it. Second, you have to calculate the moles of reactants. Refer to the example given of the equation. A and B represented as reactants. Third step, you have to calculate amount of reactant B required to react completely with reactant A. Next, you have to compare the amount of B required with that available in the system. Available here going to give by the questions. So you have to answer the questions given. If P available or present less than B required, so thus B is limiting reactant. Now, if you have B present or available from the questions more than B required from the balance equation, so then B is equal to become excess reactant. Now A is limiting reactant. So there are 4 steps you have to follow when you have to apply stoichiometric method in order to determine limiting reactant. Next method, which is ratio method, and favorable to answer the questions of MCQ, multi-choice questions. Number 1, write complete equation. Complete, again, I'm going to emphasize, complete means you have to balance it, reactants and product. Second, you have to calculate the ratio of mole to their stoichiometric coefficient for each of the reactants. For example, if you have to count the moles of A must divide with its stoichiometric coefficient and refer to the example equations above. Moles A must divide with the X, while the moles of B must divide with Y. So how can we determine the limiting reactant? So thus, the limiting reactant is the reactant with the smallest ratio here. The last one is the step to follow when you have to calculating theoretical yield. From general chemical reaction equation below, Xa plus Yb in order to produce Zc plus Wd. First step, we have to determine the mole of reactant A and reactant B. Second step, determine the limiting reactant. Reactant that gives smaller amount of product or the reactant that less than required. Step 3. Determine the amount of product formed from the limiting reactant. And finally, determine the mass of product formed which represented as theoretical yield. That's all. Thank you.